All right. When you pass data to a method, different things happen depending on what type of data you send. If you send primitive data, that's an int, a boolean, a double, then a copy of the original data is sent. And any changes made in the method to the copy are tossed when the method stops running. I'll rewrite it a little bit different. Any changes made to the method, made in the method to the copy are not do not affect the original. So basically, when you send an integer over to a method, Java makes a copy of that integer, and then over in the method, you can do all kinds of stuff with it, like add numbers to it, subtract, divide, whatever you got to do, but it's not affecting the original number in the caller. And whoever called the method, their variable doesn't change because you sent a copy over. And that might seem logical to you. It seems logical to me. The thing is, in Java, if you send over non-primitive data, that's like an object. Let's say we had a method we could call and we could send a frog over to that method and it would feed the frog or something. It doesn't send a copy of the frog. It sends a reference to the actual frog. So anything you change while you're in that method actually changes the object. We're going to learn more about this next unit, and I'm not going to test you on the object part of this. But you do need to understand that when primitive data is sent over to a method, that it's not changing the original variable. And I'll show you a specific example right now. So look at this right here. I made an integer a, and I'm going to print it out. I said main before. That's right here. We're in the main method. We're printing a, and then we're calling this method change it and sending a over, and then we're going to print out the value of a afterwards. So I'll run this, and we'll see. A is 7 before and after, right? So here's A is 7. We print it, and we call change it, and then we print it after. It's stayed the same. If we come over here and look at the change it method, change it takes whatever number you send over and adds 1 to it. So you'd be like, well, why isn't it 8 afterwards? Well, that's because when you say change it A right here, we're sending a copy of A over to change it. And that's why this doesn't matter if this is X or A. We could have had this be A. I wanted it to be different so you knew how different it is. This variable X is a copy of A with all the rights and responsibilities of a copy of A. And over here we can do anything we want to X. And then when the method ends right here, we come back here. A is still what it was because it's totally untouched. Okay, that's just with primitive data. If you have object data or custom classes, soon we're going to get into arrays, which are lists of numbers and things. That data works differently. And in fact, that's the next unit. We're going to learn all about that. So I added these print calls in change it so you could see the whole thing in all of its scary glory. So in the main method, A is 7 before we call it. And now we're in change it, and X is 7. And then we added 1 to X, and X is now 8. And the method ends, and then we're back up in main, and A is still 7, because they're just independent things. A copy got sent over. Yeah.
So is that why we say like X, or A is equal to X and stuff in our, so does that change it?
like if down here we said A equals X, we couldn't do that here because A only exists up here. See, we declared it right here.
So if we said like
If it was up here, if it said private int A, yeah, then you would have access to it. So, yeah, good question. Yeah, if we said this here, it would not compile. It would say it didn't know. I don't know what you're talking about. There's no A in here. All right. So that's that set of notes.